Hey, what's up guys? Jacob Legacy 4x4 here again, and today we're going to be doing the final video on my CNC plasma and router build that has been going on for the last couple of months here. And today I'm going to be showing y'all how to do all of the software portion of it. So this is all the stuff on the computer to make LinuxCNC work with a Mesa card, to make it work with the PlasmaC variation of LinuxCNC, and as well how to set up the router to do it as well. This video will probably be a little long, like the other one in the past. The last one I did of this, and I'm going to try to make it a little bit better so that y'all can see what I'm doing on the computer as I go. I'm still struggling to find any kind of screen capture software that would work with this to run it off of Linux remotely. So if I can't figure out how to get a screen share software to work, then I will take pictures using the camera up nice and close where you can see the detail, and then you'll just hear me talking through it with different screenshots as I go through it. Anyways, with all that said, let's go ahead and get started. For the first thing that we're going to do, we're going to work on setting up the base machine. I'm going to do the plasma cutter first, so the plasma is going to be the first thing to get set up, and then once the plasma cutter is done, we'll come back and we'll set up the router at the end. So let's go and get started. All right, so to set up the base machine, I'm not going to show you how to install LinuxCNC onto your computer. There are plenty of videos on YouTube about it. I will link to one down in the description. So if you're just curious about how to get LinuxCNC onto your computer, follow the video in the description. It will show you how to do it. We're going to pick up from a base fresh install of LinuxCNC, and I'm going to walk you guys through the process here to set up this thing. So I know that this is still hard to see. This isn't ideal, but this will work, and like I said, I'll have screenshots of the different pages and how I have them set up that will go along with this, and I'll overlay them on top of the video where necessary. Ignore all of this stuff on the left-hand side of my desktop here. As you can see, this is my testing computer that I've used to set up the machine multiple times now, so there are a bunch of different programs on here. So completely ignore that. Don't even worry about it for now. I'm going to go through a full setup of the machine from start to finish. All right, so when you come onto LinuxCNC, this is the home page. Obviously, this is your desktop. If you're not very familiar with Linux, it's similar to Microsoft, but different in a lot of ways. But it's not overly complicated. LinuxCNC makes it really easy to follow. The first time I ever built one of these, it was my first time ever really using Linux, and I was able to follow along and learn and pick it up pretty quickly. Anyway, so the first thing you're going to have to do is you're going to have to set up the network. Now, you do that because the Mesa card runs off of an Ethernet connection, and the computer needs to know where that Ethernet connection is, and it needs to be fixed onto it so that it'll work. So on Linux, you come up here to the top right-hand corner, and you will see a little plug-looking thing next to your name, and it's going to be your networking tab. You're going to go into the networking tab and click Edit Connections, and it's going to pull up the network connections kind of homepage. You're going to want to click Add. You're going to create an Ethernet connection. And it's going to pull up all of the different data for an Ethernet connection. Ignore most of it. You're going to just go over to the tab that says IPv4 settings. You're going to click on that. And then in your additional static addresses, well, hang on, you're going to go to Method, Manual, and then for addresses, you're going to click Add. And the address you're going to be using is going to be 10.10.10.11. Net mask is going to stay at 8, and the gateway won't change at all. Once you've got that done, come down to the Routes button, click Routes, and click Use this connection only for resources on this network. That's all finished. Go ahead and click Save. And that will make your connection. When you name it, you can name it whatever you want. I personally named it CNC connection, but you can name it whatever you want to name it. It's your own little network. The only thing that's going to ever see this is your own computer. Now, when you do that, when you do the routes thing and you say use only for resources on this network, it should hopefully allow you to have Wi-Fi, should you choose to have Wi-Fi. This computer does not have a Wi-Fi card on it, and my other computer doesn't have a Wi-Fi card on it either. So the computers I use out here, I don't personally run off of Wi-Fi. I feel like it kind of clogs everything down, and I don't have a need for it. I transfer files through SD cards, and that is how I get data from inside the house on the CAD software to outside in the garage where I'm going to use it. Anyways, with all that done, now it's time to actually set up the configuration. In the top left-hand corner of the window up over here, you'll see a little applications window. Left click on that, and you're going to go down to where it says CNC, and then come over. It'll pull out a drop-down menu, and you want to click LinuxCNC PNC configuration. This is the configuration window that's specifically designed to set up Mesa cards with LinuxCNC, and so you're going to make sure you do this. If you use the other one, step configuration, that is not designed for Mesa cards, and it won't work. That is only designed for parallel port cards. Just gives you a brief description of the way the machine works, or the way LinuxCNC works, and a little like welcome letter. And you're going to come over here to the top right hand corner, and you're going to click Start. Now, in here you have the option to create a new configuration, modify an existing one. We're going to be creating a new one for this case. And then you have some options to either create a desktop shortcut, create a desktop launcher, and show the advanced option pages. I'm going to click all of those because you are going to want to use some advanced options potentially. And I like having desktop shortcuts for both the files, for when you inevitably have to make some adjustments to the files, as well as to launch the program so you can launch it straight from the desktop. Go ahead and click Forward. First thing it's going to pull up is a page that says Base Information. You can name your machine whatever you want. I'm going to name the machine PlasmaCNC version 2 because this is my second time doing this. You can name it whatever you want to name it. You have the option to include the spindle or not. I am not using a spindle on the plasma cutter, obviously, so I'm going to check that off. Over here on the right, right here, you have the option for XYZ, XYZA, or XZ lathe. Those are just the type of machine so that LinuxCNC, the configuration wizard, knows how to set everything up. For this, you're going to go XYZ. I know that there are, there's an extra motor, an extra control system, but you're going to do XYZ. I'm doing it in inches. If you use millimeters, that's fine. I'm American, so I look at things in inches. For the I/O control ports and boards, make sure that Mesa 0 PCI Etho pair port is checked, and then none. And then down here at the bottom, you've got default options. Require homing before running. Pop-up manual tool change prompt. You can leave the spindle on during tool change. Force individual manual homing. I'm going to check that. Move spindle up before the tool change. I'm going to check that. Restore joint position after shutdown, and random position tool changer. Those are up to you. If you want to have those kind of things on there, then you can have them on there if you'd like. But if you're not going to use them, or if you don't know what they are, just leave them unchecked and keep them turned off. Actually, you're going to click Forward again. This is going to give you to your screen configuration. I'm choosing to stay with Axis. There are 4 of them that you can pick from: Axis, TK Linux, GMOCAPI, and Touchy. I like the Axis one the best. It is the most well designed for a desktop computer like this. A lot of the other ones are based off of running like a touchscreen, if you're going to use a touchscreen for this application, but that is not how I choose to run this. You can change those. There's videos and images online that show the differences between the way they look, and you can pick one that you like better if you don't like the Axis one. All right, for your general graphical user interface defaults here, position offset, you want to leave it as relative. Position feedback actual. Display geometry is XYZ. And down here is where you're getting into some of the fancier stuff here. So here for axis defaults, the default linear velocity. Now you can set this to whatever you want. I would recommend keeping the default linear velocity relatively low. That way, if you accidentally click a button, or if you tell the machine to go do something in default, it doesn't slam into something else on accident at full speed. So my motors and the way this machine is built is able to handle up to 1,000 inches per minute. I am going to set the default linear velocity to 100 inches per minute. Next, you have the minimum linear velocity. I set it down to 1. That's fine. And then maximum, I'm setting at 1,000. I'm not going to touch the angular velocity stuff because they work well enough for the z-axis as is. For the increments, they go from 0.1, 0.05, 0.01, etc. You can change those, you can add those, you can delete those if you want. All that does is it changes the scale, the visible scale within the system. I'm just going to leave it as the default. And then the last thing I like to click is force axis to maximize. I like to click that one when you open up LinuxCNC as an application to run it. That will force the application to take up the whole screen, which is how I like to run it. You can choose to, check that or not, up to you. And the last thing I didn't talk about was these max spindle, min spindle, and max feed overrides. I'm not touching the spindles because the plasma cutter doesn't have a spindle. And for max feed override, I leave it at 200%. That allows you to overclock it if you want, but that is an option you have to specifically check. You can leave it down at 100, it doesn't matter. All right, moving on, you're going to click forward again. This is your custom BCP panel. This is where you can view things like the spindle speed, or any additional data you would like to be visible from the plasma cutter or from the control board to the computer so that you have status lights and things like that. For the sake of this example, I am not going to turn any of these things on. As you can see, I'm just going to kind of skip right through this screen and we're not going to use any of this. As you get more and more comfortable with LinuxCNC, you can come back through and fine tune this and add additional features you want. But the point of this video is to show you how to set up a base machine. So just go ahead and click forward here. Now, this is external control stuff. This is some of the advanced option things. If you did not click advanced options, this page would not show up. But this is if you wanted to add, a different type of VFD, if you had like a joystick to do jogging, feed overrides, stuff like that. So if you're not going to be doing some kind of external jogging or external control of any kind separate from the computer, then you don't have to worry about any of this. I just kept this in the video just so that y'all would be able to see what kind of options you have. All right, now to the fun part. This is where you're going to actually start setting up the Mesa. So everything we've done before this was basically just setting up the machine-based parameters, showing the machine, hey, this is what I'm working with essentially, and then doing some of your graphical user interface fine-tuning. On this Mesa card page, because you only have one card, it says Mesa card 0. When you're speaking with Mesa cards and with LinuxCNC, 0 is 1, if that makes sense. Up here at board name, you're going to change the board name to whatever type of Mesa you have. In my case, it's a 7i76e internal data. And then for the card address, you've got to change it to 10.10.10.10. You can adjust the base frequencies and all that stuff if you want to. I am not going to. But again, as you get more and more familiar with this and more comfortable with it, you can really fine tune this a lot by coming in here and changing all this base stuff. Once you are good with all of that, and you've got the card address correct, you've got the board type correct, then you're going to click Accept Component Changes down there at the bottom. Click Accept Component Changes. This pulls up 4 additional tabs on the same screen here. And the first one's going to be I/O Connector 1. Now, in I/O Connector 1, this is where your step generation stuff comes from. So this is your TB2 and TB3 pins on the Mesa board, respectively. Now, the way I have mine wired to be X, Y1, Y2, and then Z. If you have it the same way, then that will work for you as well. If it's different, then change it accordingly, obviously. So over here on number 0, you're going to go axis, main axis, x-axis. For 1, axis, main axis, y-axis. For 2, axis, main axis, or a tandem axis, y2 axis. And then for the next one, you're going to do z-axis. Now, once you get those in there, that tells the machine which pins on Mesa correspond to the respective motors on the machine. Now, with your Y and your Y2 axis, on your Y2 axis, click the invert, which is the small check on the right-hand side of it. Inverting it is what is going to allow the 2 motors to work together without binding on each other. Obviously, because of the way the machine is, if they both spun the same direction, the machine would try to go 2 different ways and it would bend the center gantry. So one of them needs to be inverted. I choose to invert Y2. I/O connector 2 and 3, you should not have to touch at all. Those, at least in my case, and in most cases, you're not going to use those. Those are just excess connectors. And then over here at 7i76i/O, that is your inputs and your outputs for your limit switches. So over here, again, the way I have mine set is mine go Xmin, Xmax, Ymin, Ymax, Zmin, Zmax. So I'm going to do that in order from 0 down to 5, and that is going to be for my limit switches to tell the machine where the limit switches are and which one is actuated. Actually, quite small alibi. I forgot to mention, you only do for the X and the Y. If you're setting up a plasma cutter, you do not put the Z-axis limit in here at this point. You do that later when we get to the PlasmaC configuration. Same thing with all the other outputs. I'm not using any outputs for this. You're going to do the plasma output during the installation of PlasmaC. So for right now, you're not going to need to have that up. Your limit switches and you've set your step gens, you just click forward again, and now we're going into setting up the motors here. So first thing you're going to change is the drive type. In my case, I'm using a Gecko 201. If you're using something different, LinuxCNC has the majority of common drivers loaded in here to give you your stepper information for that driver. However, if you're doing something different or like a random type driver, you'll click custom and you have to follow the instructions to get that information. Next thing, you're going to go to calculate scale. Now, the Gecko drivers, the 201s, have an automatic 10 microstepping function. So up here where it says stepper motor scale, make sure you change that, check the box there, and then change it to 10. And then motor steps per revolution. If you are using a 7 amp NEMA 34 motor, which is all of the Avid CNC ones and most of the common NEMA 34 large motors that are used for this kind of stuff, you're looking at approximately motor steps per revolution of 203.7. Verify with your motor the correct motor steps per revolution. There's a math equation for it if you want to do it, but make sure you verify that information when you come in here. Put that down where it says motor steps per revolution, click enter, and it's going to calculate out the scale for that motor. And then below calculate scale, you're going to change the maximum velocity to whatever your motors are capable of, and your maximum acceleration you can leave at 30 or change it to whatever you want. Obviously, the faster the machine is moving and the faster it's accelerating, the more structurally sound the machine will have to be in order to maintain those kind of speeds. My machine, the way it's designed with the steel bed and then with the aluminum extruded rails, is capable of handling that 1,000 inches per minute. However, some machines are not, so that might be a little high for certain machines. If you want at this point, you can test and tune the axis if you turn the machine on and you can see the axis move, but I know that it works, so we're not going to do that. Now, in the next screen, you're setting up the limits for the x-axis. Up here at the positive travel distance, set it up to whatever the maximum size of your machine is. Mine happens to be 50 inches, so I'm going to change that to 50. And then you can change your home search velocity and all this other stuff if you choose to. I don't ever have the machine auto home. I manually home it every single time because I don't like auto home function since you could cause a wreck and cause damage. So because I have time and I'm patient, I just manually home it each time. So I'm not worried about all the homing functions. Click forward, comes to the Y motor, and we're going to do the same thing for all of these motors. The same exact thing here. 203.718. Microstep is 10. Enter. apply. Change all those and keep going forward, forward. The Z motor, I do the same data for the Z motor. The only difference is the lead screw metric pitch on the Z motor is 5, microstepping of 10. And so that's going to change that data. Boom. This next page is another one of the options you have if you want to include some user interface components and commands and stuff like that. You can play around with this, and this gives you the option to add some additional custom features to the machine should you so choose to. Again, for this, because it's a base machine, I am not going to do that. And that's it. Now you're done. Next thing you do, you would click done. This would save the program, make the desktop shortcut, and then would allow you to start to play around with the machine. So that is going through the basic setup of a basic machine on LinuxCNC. Now I'll show you guys that the machine moves and jogs and that the limit switches work and stuff like that, and then I'll show you how to do the PlasmaC configuration. What you got to do, obviously turn on the machine, switch your power switch, and you can see that it's almost homed right now. I'm going to come over to my PlasmaCNC app here. As you can see on the computer screen, I've got LinuxCNC running, and the machine is stationary. Top left-hand corner of LinuxCNC, there is a red X directly below the file button. That is like your on and off button that gives the machine power, or soft gives it power through the software. Click that to give the machine power, and then next to it there's an orange power button, and that is the enable function, so to speak. So you got to click both of those in order to get the machine to connect and be ready to jog. Now at this point, if it's homed, you can go around and home your different joints. So LinuxCNC works from a joint system, and so there are 4 individual joints on this machine. Between the 2 Y motors, the X motor, and the Z motor, there are 4 different joints. And so when you go through and you home each of the joints individually, you're verifying that each joint is where it's supposed to be. You click home on all of them, and then after that, the GUI here will transition to X, Y, and Z. And then from that, now you can jog the machine around. I'll do the X-axis here. You can see the X-axis moving like it's supposed to. And the Y. LinuxCNC has pretty good soft limits in it, so you can see that I usually don't set it right on the limit switches when I home it. I give it like an inch, half inch to an inch of space. Those limit switches are for emergency use only. I want, when one of those things hit, the thing needs to stop immediately, and I don't want it to accidentally click on it for no reason. And so I usually just trust the soft limits on LinuxCNC to control the machine's kind of left and right boundaries, so to speak. But if something were to happen, those limit switches are there to protect it and to keep the machine from ramming into something at full speed. And lastly, there's the Z-axis moving up like it's supposed to do. Doing exactly what it's supposed to do. So, there we have it. The machine moves, and that is the most important part. And you can come up here, and if you click on one of those, you can maybe see it on the screen here, all of the errors that just popped up. Essentially, that just told the machine, hey, I hit a limit switch, stop everything. So, the base machine is set up. Now we got to move on to setting up the plasma component. All right, so now up to this point, we have set up the base configuration. Now this base configuration is, again, like I said, the basic information that's needed to make the machine move and jog and kind of behave like a computer-controlled machine would do. Now we're going to move on to setting up the plasma configuration. So we're going to get into that here in a second. But one quick note, like I said, some key things to note when you're setting up a base machine for the plasma setup, include all of the limit switches except for your float switch for your plasma head, because you're going to set that up during the PlasmaC configuration. And if you do it during the initial base configuration, it will come back with an error and you'll be frustrated. So just do not include any of the Z-axis stuff whatsoever. So I only included the limit switches for the X, the Y, and the emergency stop button. Now, also, if you go set up a router, I'm not going to go through the process in this video to set up the router configuration because it's identical to setting up that base configuration that we just finished. The only difference is that you include the spindle control stuff in your list of outputs. There's a whole section in that little Mesa section that shows all the spindle data. So in that section, it says spindle on top of it. Fill out all the appropriate information for the type of VFD you're using and for the type of spindle that you're using, and that's where all of that will fit. So we're not gonna go over the router configuration because it's exactly the same. I'm trying to save some time here, but let's move right on here into setting up the plasma connection specifically. Also, my wife and I got a new dog, and she likes to play with beer cans, apparently. And no, we have no idea what kind of breed she is. She was a rescue from the shelter here. Same place we got the other dog from, actually. That dog doesn't drink beer, but this one does, apparently. So moving along here, after you've got your base configuration set up, what you're going to do is you're going to go to the top left-hand corner to Applications and open up a terminal. Now, if you Google the PlasmaC user guide on the LinuxCNC website, it'll pull up all this information and you can follow along in there, or you can look at the picture that I'm about to put up on the screen here. Now, you're going to type in a string here of information that's going to pull up the PlasmaC configurator. I'm not going to say out the string because it's kind of long, but you can look at it. I'll show you a picture of the completed string here. All right, so you're going to type in that string of information, and then you're going to click Enter, and it's going to pull up the PlasmaC configurator window here. In your case, you're going to click New. However, if you were upgrading the machine or reconfiguring something because it went wrong, you've got the Upgrade and Reconfigure options. In New, click Continue, and then it's going to pull up this blank PlasmaC configurator screen. Now from this screen, this is where you're going to start inputting all of your individual data. You can call the machine whatever you want. I'm calling it PlasmaCNC. You need to search for the INI file. So if you go to wherever your base machine is, go to that folder and then click on INI. There's a .ini file in there. And then same thing for the HAL. Pull up the INI and the HAL files there. All right, so your next option is you've got a little window here that says use arc voltage for both arc OK and THC. And there's 3 modes, mode 0, mode 1, and mode 2. This determines how the machine is going to read arc voltage and arc OK. If you do mode 0, it's going to use arc voltage to give you both arc OK as well as your THC control. Mode 1, which is the mode that we're going to use, means that there's a separate arc voltage and a separate arc OK pins on the Mesa board. And so the Everlast, on the back of the Everlast, it does have an arc OK output. And so we've got that wired up. So we're going to use mode 1 in this case. You'll have to change that mode based on the type of machine that you have, the physical plasma cutter, and the way you have it wired. But if you followed what I did and you're using an Everlast machine, it's going to be mode 1. Now, the next box is arc voltage HAL pin. That is your arc voltage pin, which is going to be used to calculate voltage and then adjust the THC accordingly. So for this, we're going to map it to the thc-ad, and in order to do that, you're going to type in this hm2 7.60.0.00.velocity. I'll show you guys at the end here right what all of this looks like completely finished, and you can copy this directly if you are using a 7i76e like I am. All right, next is going to be your arc OK pin. Like I said, this is a separate input pin for the arc OK. In my case, I have that wired to the Mesa 7i76e input. The torch on, the next box down, is going to be for turning the torch on and off again. So you're going to wire that to wherever you have it on the output. I have mine on the first output, which is output 00. Your next option is a run frame or a run tab. So you can either do a run tab or a run panel. I like to do the run tab. It basically gives you a separated tab on the LinuxCNC application window that you can click to if you need to make any adjustments to it. Another option is to do run panel, and that takes up some space on your front GUI. I don't like that as much because I like to see as much of the machine's processing as I can. So I just use the run tab because I very rarely ever change that data on the fly. All right, and then the last one we're going to put on here is the float switch. This is what I was talking about a few minutes ago with All right, so the next thing we're going to do is we're going to map it to the float switch, and that float switch is the Z minimum. It's that limit switch that tells it when the torch has touched the material, which gives it a frame of reference for where to start the cut. All right, so with all that done, this is what this looks like, as you've been able to see. Now, the next thing to do would be to click Create, and then it's going to create another configuration file for you, and it's going to tell you where that file can be mapped to if you want to run it through a terminal. I'm going to show you how to make a desktop icon for it here in a second. Anyways, go ahead and click Create, and that is going to make your PlasmaC configuration. You can then close the terminal window and go back to the desktop. Now, there's one more step you got to do. You've got to find your HAL file for this. You can go to Home, LinuxCNC, Configs, PlasmaCNC, and then that is going to have all of your data in it. Now you're going to open up your HAL file with the text editor. And down at the very, very bottom of this file, you're going to want to add a couple lines. Again, I'm not going to say all these on the camera here because you can just look at the picture and follow along. You're going to want to add all of the stuff that I have underneath the Mesa codes line, and just a little basic coding thing here with Linux, or at least with the program here for LinuxCNC. If you do the hashtag, the £, if you do the £, whatever you write after that is going to be commented out, so it is not going to be used for any of the data. So you use that for like naming conventions and for organization. And then what you want to do is you want to copy these 3 set P lines that are down there. So it's set P, HM2, etc., etc. Copy them exactly the way they're written on here, as you can see, and add them in their HAL file. Click Save, and then Close, and you are good to go. Now, the next thing we're going to do is I'll show you how to make a desktop launcher for the Plasma configuration. Your desktop, and right-click, and then go down to Create Launcher. It pulls up this little launcher GUI that you can see. You can name it whatever you want. So I'm naming it PlasmaCNC. Write nothing in the comment. And then in the command line, you're going to copy that link, that string of text that was given to you when you finished the PlasmaC configurator. Or if you want, you can just find it as a file in here. So you pull up into the select application. Find your PlasmaCNC INI file. The INI file is what the LinuxCNC application uses to run the actual application. It is a text document, or it can be opened with LinuxCNC, and when you open it with LinuxCNC, that is what runs the machine. So double click on that, and then in the command line, go to the very start of it and just type LinuxCNC space. You can change the icon to be whatever you want it to be. I'm going to just use the LinuxCNC icon. And then check Run in Terminal. It should look like this. And in that command line, it's LinuxCNC space, and then it's the address to wherever your file, your INI file, is saved. If you get stuck on this, again, the PlasmaC user guide has a detailed walkthrough in text of how to establish a launcher. Once that launcher is done, you can turn on the machine and you can open up the PlasmaCNC application using LinuxCNC from your desktop, and you can test everything to make sure it works. Let me go and show you guys what that looks like. All right, so I'm just gonna do a quick test. You are gonna be able to hear the plasma cutter running in the background, but I'm just gonna show you guys how everything works now that it's set up. All right, so starting just with a quick little jog here, you can see that's the x-axis moving like it's supposed to. And you can see the z-axis moving. All right. Next thing we're gonna do, we're just gonna check the pulse. All right, the float switch is working. And the last thing is just to do a pulse of the torch, just to show that the torch works. Perfect. From here, you guys can see the window for LinuxCNC. You can see that the THC is enabled, and then all these little panels down here just give you information on the machine as it's operating. When you put a file in, it'll come up in here and it'll show you the dimensions of it, how it fits on the table and everything like that. And then you can see all of your different axes, your jog commands, your pulse, etc., etc. Again, like I was saying, there's an X and a power button up here. Those are what enable the machine. You have to home all four of the all the joints individually, and then it'll bring up the XYZ mode. There's your jog functionality. You can set it to auto home if you want. Like I said, I don't like to do that, so I don't have it set like that. You got your torch pulse option, which is what I was just using there to show that the torch was functioning. That'll just manually make the torch pulse to do a check on it. And that's about it. And then you have your feed override, your rapid speeds, and all that kind of stuff down here to adjust if you want. Over here in the run window, this is where you have all of your cut parameter stuff. So as you come through here, you can set up different plates of steel. You can see like I've got a 14 gauge, an 1/8 inch, 3/16 and a 1/4. You set those up, and then that's what gives you the data for the rate that it cuts, the speed that it cuts at, the height that it cuts above the plate, and then it gives you some data for how it controls the THC. You got some probing stuff here, some THC stuff here. You can familiar yourself, you guys, with LinuxCNC. There's lots of information on YouTube and in other places about how to use it, but this is it, fully functioning. This is what it looks like. All right, so that completes this video. As you guys can see, everything is fully operational now. The machine works and moves around like it's supposed to. Again, I'm not going to go through setting up the router because that would be repetitive at this point. You set up the router the exact same way you set up the Plasma one. You just don't do the PlasmaC specific configuration there at the end. Everything else is exactly the same. The only big thing to know is just check and make sure all your connections are correct. Double check your wiring once you start to set this up if you're having any issues. And make sure that when you type stuff in there that you're typing in there properly and correctly, because one little digit off could cause a lot of problems with your machine, and it might be hard to diagnose it. So just take your time with it, put it in there as accurately as you can. Anyways, that completes this video. I've got to wrap this up early. I'm actually not even going to code the router myself yet because Matt is coming down today, and we're going to work on a new truck that he got. So Stick around for those video guys. We've got a lot of that kind of stuff coming. I hope this was a little bit better and a little bit easier to watch than the previous Mesa video. If you have any questions, feel free to drop them down below and I will do my best to answer them. And be sure to check out the LinuxCNC forum. You're more than likely going to find your answer on that forum, and if you can't find your answer already there, the guys there are very helpful and they're very responsive. So if it's something that I don't know or if you need some more advice, definitely jump over there and give them a look. I referenced it a ton as I was doing all of these builds for this to get everything set up and functioning. But anyways, I've got to do some test cuts on this, make sure it's working and it's scaled appropriately so that Matt and I can use it this weekend to build some stuff. I hope you guys liked it. Make sure to like, share, and subscribe, and take care.